Right, so up to page 56 in your notes, we're looking at 7.6 intersectional lines.
Seriously, I only bring my new book today. I didn't even get it out. How much is it? $1 or something?
Okay, so intersection of two lines. So when we did equations, we looked at simultaneous equations. Okay, so we had two equations with two variables. So the variables could be x and y, or any combination of letters that we can have. Okay, remember we can only solve for a certain number of variables if we have the same number of equations. Okay, so if we have two variables, x and y, okay, we must have two equations. Alright, to get the same solution for both those equations. Okay, otherwise there's an infinite number of solutions available if you have two variables and only one equation. Okay, so that is there. So that application is the intersection of lines. Okay, so basically, so far this topic you have done, I have been told that you have done the distance midpoint gradient, you have done the equation of a straight line, and you should already be reasonably familiar with it from year 9, year 10 work. Okay, and now we're sort of venturing further from, venturing more into that, sorry. So, so did we use the method? So we had the simultaneous, we had the elimination method, okay, and the substitution method. So if you don't remember how to do those equations, you will need to go back into the notes that we'd done way back in chapter 3, which was now done quite a while ago, and get yourselves up on those skills. Alright, so examples A. Here are your two equations. Y equals 3x. Take away 1, sorry. And y equals negative x plus 7. Alright, part of the question also says graph. Okay, so when I say graph, what I want you to do now is do a quick sketch. Okay, so you have covered the equation in a straight line. Okay, so these both equations here are in the form y equals mx plus b. Okay, so m represents the what? The gradient, how the line slopes, and what does b represent? Where it crosses the y-axis, the y-intercept. Okay, so these two equations in that form, so let's do a quick sketch. Okay, so I'm not using the ruler, so you just want to get an idea of where these two lines lie, and then we're going to solve for the intersection point. Okay, and the reason why we do this is we can check our answer at the end. Does it make sense in context of the question? Right, so y equals 3x, take away 1, equation 2. So crosses the y-axis at the sign as well, so negative 1, so somewhere down there. Alright, and the gradient is 3, so that means it goes up 3 for every 1 it goes across. Okay, up 3 and then 1 across. So the gradient is the rise over the run. Okay, so m is rise over run. Okay, and calculus is very heavily based on that concept. Okay, and we'll talk about more about when we get into that. So if the gradient is 3, okay, so 3, therefore the denominator must be 1. Okay, so that means we go up 3 points and we go along 1. And that's another method we can use to plot the line. Okay, so we go 1, 2, 3, and then across 1, plot that point. 1, 2, 3, and then across 1, plot that point. Okay, it's another way we can sketch our lines. Okay. Right, the second one, y equals negative x plus 7. So the gradient is negative 1 over 1. Okay, so when we have positive numbers, it means it goes up. The direction of the rise is upwards. Okay, and the direction of the run is in the positive direction on the x-axis, or going to the right. When you have the minus sign, okay, that means you have to go down, but you still got to go across 1. Okay, plus 7, so we're somewhere way up here for the y-intercept, and then the gradient is minus, so that means we need to go down 1, but still go to the right 1. So the denominator, you always go to the right. The numerator, you take that sign and you go up or down depending on that sign. Okay, So, in other words, it's going to be 45 degrees to the axis there, the acute angle there. And you also covered the gradient using the tan ratio, okay, because that's exactly what tan is, the rise over the run, the opposite over the adjacent. Right, so what we are doing now is we are finding that point of intersection, okay? So we've got a point in the first quadrant, so my answer should reflect that, shouldn't it? Okay, so I shouldn't have anything negative in either of my answers. So we need to solve using our simultaneous equation skills. We had the substitution method and we had also the elimination method. Right? Which method would you use to solve these two equations? I would use substitution. Why?
Because you can't completely get rid of one.
Yes, but when we have an equation with x or y as the subject, so both of those equations has y as the subject, it's easy to just substitute into the other equation, okay, rather than trying to use the elimination method. Alright, so let's do equation 1, put it into equation 2. Okay, so every time there's a y in equation 2, I'm going to put in what it equals to from equation 1. So 3x take away 1 equals negative x plus 7. Okay, and I've been telling you 90% of your course is based on algebra and equation. Okay, so all the skills you have learnt in chapters 2 and 3 are being all applied in the 4 after chapters up from that. Right, step 1, get your variables over to the left hand side. Alright, keep them underneath each other. So 4x take away 1 is equal to 7. Okay, so that part of it eliminates. We've got all the variables on the left hand side. Step 2, move the constant terms onto the right hand side, performing the opposite operation on both sides of the equal sign. So 4x is equal to 8, and then now you have a simple one-step equation. Alright, let's divide both sides by 2. Both sides by 4, and the answer x equals 2. Is that reasonable compared to the diagram? Okay, so if you get x is negative 2 and you're looking at your diagram, that's when alarm bells should be going and you're checking your work. Alright, now that's one part. We need to do the other part, okay? That means finding the other variable. Doesn't matter which one, doesn't really benefit greatly from what you do. You will get the same answer. However, I am going to put it in equation 1. Alright, so y is equal to 3 lots of 2, take away 1, so 6 take away 1, which is 5. Okay, and again, yes, it's reasonable compared to my diagram. Okay, I have a reasonable solution. And determine the point of intersection. Therefore, intersection this time, instead of just doing simultaneous equations where we just had x equals this, y equals this, you are now referring to a point, so you need to put it back in that format for your answer. You are specifically the point of intersection, so your answer needs to be a point of intersection. Okay? Right, here's part B. Okay, now we're not going to graph it because I want to focus more on the skill of the algebra and the equation. Okay, and we can go to graphing when we do the actual functions and graph topic. We'll worry about that then. Right, so the first example we used the substitution method because we had a x equals or we had a y equals, alright, and it's easy to substitute into the other equation to to solve for that one variable. Okay, this particular one is not so straightforward. Okay, I mean it can be done, but it's going to be a bit of work, bit more extra work involved than what we've done here to get it set up. Okay, so the second method is the elimination method. Okay, so equation 1. With one of the variables, if we have the same number with or not without the same sign, okay, we can add or subtract the equation together. Okay, so both the x variables has a positive 3, and if I want to eliminate the variable, okay, I'm going to do a subtraction. Okay, what this will achieve is eliminate the x variable, and we just got an equation involving y variables. So 3x, take away 3x. Okay, so you're taking away the same thing from the original start, and then you're left with 0. Negative 2y, take away a positive 7y. Alright, negative 2y, take away a positive 7y. You've got to watch your sign. Opposite sign results in negative, so you're doing a negative 2y, take away 7y. So negative 9y is the result of that. Now you've got positive 9, take away a negative 18. Okay, positive 9, take away negative 18. You watch these signs. Right, same sign will result in a plus. You have 9 plus 18. Right, and then 0 take away 0, which is still 0. Alright, algebra skills. So, negative 9y equals negative 27. Divide both sides by minus 9. You get y equals 3. Alright, remembering your sign. Negative divided by negative or negative multiplied by negative will result in a positive. Okay. Right, so that's one part of the solution. You need to get the other part now. So that's back into equation 1. Like again, doesn't really matter. Okay, you get the same solution if the substitution is done correctly. So 3x take away 2 lots of 3 plus 9 equals 0. So we're now solving for the second variable. Right, this is a multiplication. So you had 2y, which is 2 times y, so it'll be 2 times 3, with the minus sign out the front. Okay, watching the signs as you're working it through. Get x equals negative 1. Alright, so therefore intersection at minus 1 and 3. Don't forget your order, x comes before y in your coordinate, so if you put 3 comma negative 1, I probably wouldn't take the mark off you, okay, but there probably are teachers out there that would. Okay, so make sure you get them up there. Right, any question? About to step it up a gear, so are there any questions that people need clarified now? Alright, let's do something a bit more tricky. Well, not so much tricky, but more involved. Right, 2x plus 5y plus 4 equals 0. 3x take away 2y take away 13 is 0. 5x take away y take away 17 is 0. We are asked to show it is concurrent. Have we seen that word before? Common point. Okay, So lines, all three lines all cross over the same point. That's what concurrent means. Okay, so it is the same approach in terms of setting up your equation and solving them simultaneously and getting an x value and a y value. Alright, but then you have to show that that's the same intersection point with the third line. Okay? 1, 2, and 3. Right, so as well as the substitution method and the elimination method, right, within the elimination method we had also stepped it up a gear in terms of changing the equation so that we can use the elimination method. Alright, so look up there and there's no, if I'm going to use the substitution method, I'm going to have to rearrange one of the equations. Okay, you get y the subject, and I'll probably do that with number 3 because y is already by itself, like in terms of no numbers with it, except for 1. Alright, I'm also looking at the equation and there are no two equations where the variables are the same. Okay, so if we're going to use the elimination method, and I'm pretty sure we covered this way back when we did it in the previous chapter when we'd done it. Alright, we had to change one or two of the equations. So if we look at equation 2 and 3. Right, so I can see the y terms, it has the negative 2y and it also has the negative y. Alright, so if I want to get the same number in the front of the y terms, okay, that means I need to have a 2 here. So if I do equation 3, and I'm going to multiply every single term in equation 3 by 2. Okay, so each term, so 5x times 2, negative y times 2, and negative 17 times 2, and 0 times 2. Alright, so we're simplifying when we solve equations usually, but now we're going back the other way. Okay, we're actually making it more involved so that we can actually use it into our equation. Alright, let's call that equation 4. New equation, you're referencing your work, so it makes it much easier to follow what you're doing. Alright, so we have negative 2y and negative 2y in these two equations here. Alright, so if I add them together, like I've done here, 3x, sorry, if I take away 3x, take away 3x, it will eliminate the x variable. I'm going to do the same here. So equation 2, take away equation 4. Watching your sign. Actually, let's swap that around. Let's do equation 4, take away equation 2. Why did I do that? Okay, the variables in the fourth equation are larger. Okay. Alright, so 10x, take away 3x. Alright, so equation 4, take away equation 2. 7x, watching your sign, negative 2y take away negative 2y, because they were the same, we were eliminating that variable, and that was the whole point of what we're doing. And now you have negative 34, take away negative 13. Okay, you've got to watch your signs here. So the two negatives make a plus. 7x, so negative plus 13, so it becomes a negative 21. So negative 34 plus 13, negative 21. Alright, and then you have 0, take away 0. Okay, so this skill was covered in chapter 3, and when we did simultaneous equation, we're just now applying it. Alright, so let's solve our equation. So x equals 3. Right, at this point I'm going to use either equation 4 or equation 2. Okay, I'm not going to use number 1. Again, doesn't really matter what you do unless there's one fairly straightforward that you can use. It makes it nice and simple. Equation 3 even, because equation 4 came from equation 3 and we just had a y there. Actually, I'll put it in equation 3. Alright, so the extra 5-10 seconds you can take planning your work can save you minutes of work later on. Alright, equation 3. So we've got 5 lots of 3. Take away y, take away 17, which equals 0. Right, so y is negative here, so if I move that over the other side, I'm going to get my positive y, which is what I want. 5 3 is 15, take away 17, which equals our positive y. So y is negative 2. Okay, so the point of intersection for those two lines, x is 3, y is negative 2. However, the question asks you to show that those three lines are concurrent. Alright, so you will need to show, because we have not used equation 1, we need to show that that satisfies that equation as well. So, am I going to go through and do all that work again in equation 1? Why not? So?
You just put those into one.
Exactly. Right. So if we show that x is 3, y is 2 satisfies this equation, it is also a point on that line because the left-hand side equals the right-hand side. Okay, and it's already a point that satisfies the other two equations. Okay, so the point is valid in your third one, therefore the equation itself. Wow, isn't you bored? Anyone see how much easier that was to roll?
I don't think it's a new board.
Hey?
Yeah, it is.
Yeah,
It is.
fantastic.
Oh, cool. Oh.
I'm going to lose all my biceps now. Alright, so,
You can see all the blood in the belt.
hey,
You can see all the blood in the belt.
Do I know what that is, though?
I don't know. Oh, it's like a pinboard. Anyway, alright, so x is 3, y equals negative 2. Let's put that in equation 1. And if it satisfies equation 1, then therefore it also is the common point that satisfies our other two equations. Alright, so 2 lots of 3 plus 5 lots of negative 2 plus 4 must equal 0 if that's the point that satisfies. Okay, so 6, take away 10 plus 4 is 0. 6 plus 4, 10. 10 take away 10, 0 equals 0. Yes. Okay, so instead of going through simultaneous equations again, okay, you can see how much time that can take when something can be done a lot quicker to get the answer. And you are told that they are you are asked to show that they're concurrent, so obviously they must be. Okay, you just have to show it. Okay, and that's how you show it. So therefore, lines are concurrent, or you can say lines intersect at the point. And again, remember your order, x's before y's.
Are you okay?
You have gastro. Sadly, no. I wish.
Right, any question? Alright, so when there will be exercises in your in exercises that ask you to concurrent, and that's how you do it. 12:55, isn't it? 15 minutes. Alright. Now time for something new.
At that time.
through the intersection of two other lines.
Why do you capitalize everything?
Well, what?
That's what happened.
Like capitalize, you capitalize every letter, you can, every letter you can
No. The line through.
That is capitalised. Okay, so this one you are given the equation of two lines. You are also given a separate point, and you have to find the equation through those 2 points. Okay?
It's two separate ones.
Choose two lines and a point, and you have to find the equation through the intersection of those two lines and the other point. Right, in your notes there's formula. So this is one you need. Alright, there's your formula.
Not even long.
The formula itself is much shorter than the working you need to do.
It's almost as easy.
Wait, you said shorter than the letter.
Alright, so to do this we first find the value of the constant, which is labelled the letter K, by substituting all the information of your two lines and the external point of those two lines, or not the intersection of those two lines, and then we substitute it all back to find the equation of that line. So let me illustrate it with an example. Right, D, so under that heading of intersection of lines, because that's what we're still doing. So the point is 1, 8. And the two lines are x plus 3y plus 5 equals 0. And we also have 2x take away y take away 18 is 0. So the point they give you is not the intersection point of those two lines. Okay? The point there, 1, 8, is not the intersection of those two lines there. Okay? So, basically, if we, I'm not saying this is accurate, I can make the point accurate, okay? There's the point, two lines cross over like that intersection point there, okay? Because for an equation line, you will need 2 points. You are now finding the equation of that resulting line through those 2 points. Okay, this is what we're doing. So, we proceed as follows. So, this is A1, B1, C1. This is A2, B2 and C2. Alright, that's where the variables come from in this equation. And then of course x's and y's are the point. So this is x and this is y. And that's what you need to substitute into the formula, which is provided for you in your notes. So, if we put it into this formula, substituting all the variables, so the only letter you have left is this k. You will then solve the equation for the value of k there, and then we'll go an extra step after that. So, A1, which is the coefficient of the x there, right, so it's 1 times x, so this is a point at x, so 1 lots of 1. A1x, which is 1 and 1. B1, which is coefficient of y in the first equation, so 3. And then to multiply that by y, which is the y value of your coordinate, plus C1. So from the first equation, remember we had A, B's and C's for your quadratic, it's pretty much set up the same way. So plus 5 plus k, so we're finding the value for that constant with an open bracket, and then do the same thing with the second equation. the A2, which is 2, the 2 lots of x, which is 1, plus B2, which is the negative 1, and y from your formula, so B2 times y, plus C2, which is negative 18, and all that equals 0. Okay, can everyone follow how the substitution worked? Okay, formula, variables, all in the formula. The only variable you have left is the k, and that's what you're now going to solve for. Alright, 1 times 1?
7.
Get out of my class. 3 times 8? Plus 5 plus k. Your bracket still needs to be there. Alright, so 2 times 1, which is 2. Negative 1 times 8 results in negative 8. And then you have the negative 18. Equals 0.
So what is the K? What's the neutron for it? Oh,
Okay, let me get you to do it. It's a 4
Alright, so 1 plus 24 plus 5, 30. Alright, 2 take away 8. Negative 16, take away negative 18. Oh, sorry, negative 6, take away negative 18. So negative 24, okay, equals 0.
24K, that's a lot.
Right, so plus minus becomes a minus. That means 30 is equal to 24k. Alright, so just going through your arithmetic, your algebra and your equation skills. Alright, I want k by itself, so we're going to divide both sides by 24. And what's 30 divided by 24 in the simplest form? Don't put it in your calculator. What's the highest common factor with 30 and 24? 6. So 30 divided by 6 is? 24 divided by 6?
Told you, Nicole. Come on. Hey, I got it. I said 1.25.
Well, yes, we'll keep it as a fraction. Okay? Right, so now have this, and this is now what you're going to substitute back here for k. But this time you're going to leave your x's and y's as they are. Alright? So you're still going to do A1, B1 and C1s, what you've done here, but you're going to leave x's and y's out as x's and y's. Okay? Right, so essentially rewriting this equation, so 1x plus 3y. So basically where I've got the bracket, I'm going to replace it back with x's and y's. Okay, so replace 1 back to x and 8 back with y. Plus 5, so in other words I'm rewriting the original equation. Okay, going back to the original equation. Right, plus k, which is 5 over 4. Open bracket. And rewrite the second equation up here. 2x, take away y, take away 18 is 0. Or go back to here and replace the 1s and 8 with x and y. Alright, so we don't need that 1 there. Now going to expand and simplify, getting in simplest form, in the form ax plus by plus c equals 0. What's the first thing I'm going to do?
Slide.
Expand. No, divide. Yes.
Divide. Good. Excellent. Times everything by 4. Why we do this? Get rid of the fraction. Okay, so you don't need times 4 everything in here because I've already got it out the front, a factor of 4 out the front, and that cancels with the denominator here. Okay, however, for the first 3 terms, I do need to multiply everything by 4. So, 4x plus 12y plus 20. And then, right,
18 times 5 is 90.
that is correct, yes. So, we now need to cancel the 4s. That means 5 need to be, this needs to be expanded, so 5 needs to be multiplied by each of those 3 terms. So 10x, 5 times negative y, 5 times negative 18, which is negative 90, equals 0. Collect your like terms.
No, I couldn't bother.
Okay.
14.
That is divisible by 7. There you go.
Fantastic. Excellent.
0.
You're wrong. Your mum.
Alright, if you leave it at that point, you're not entirely correct. Because of what Robin said.
I did.
Okay, each of those 4 terms has a factor of 7. Well, 0 divided by 7 is still 0. 2x.
0 is a beautiful thing. Yeah, this is also.
You could really learn.
Right. So that is the equation of the straight line that goes to the intersection of these 2 lines and that external point. Okay? What's the alternate way to do this question? You have already learnt it.
Is it the graphing one?
Hey?
No, what's that idea?
What have we done before I've done this? What did we do before this one?
Intersection lines.
Intersection line by solving simultaneously.
Yeah.
So if you solve these 2 lines simultaneously, get the point of intersection like we've done at the start of this lesson. Okay, you will have a second point, and to find the equation of a straight line, you need 2 points. Okay, so that you can calculate the gradient and write it in the form, which I will follow up on tomorrow, on Thursday, sorry.
Yeah.
Alright, so, except for Robin and Amanda, by some point by the end of this week, I will need to have a look through your books, please.
We have to have ours in my name, right?
Okay? So,
We have a 2 days.
when you get that to me, that'll be good, so I can check through it, see where you're up to in your work.